to look at and some problems to try. Let's start with kind of questions from that. It could be homework or specific homework stuff or just general stuff about the lesson. Either is fine. Taylor, we'll start with you. Yeah, so 22 is sneaky in that, like, the setup for it is a little bit tricky. So it says two concentric circle, or two toy racetracks can form concentric circles. So by concentric, we mean that they share the same center, right? So kind of like the picture I've drawn here. Each racetrack is divided into 15 identical segments. So I'm gonna not draw all 15 of them. Since they're identical, I'm just gonna kind of draw one, and it'll take, represent all 15 of them. Cool with that? Okay. If the inside car travels 1.2 centimeters less than the outer car on each piece of track, so I know S1 is equal to S2 minus 1.2. How much bigger is the radius of the outside track than the radius of the inside track? Oh boy. Oh boysy. There we go. Set up two equations using the arc length formula and use substitution to solve. Round your answer to the nearest hundredth. Okay, so my two arc length formulas would be these. I'm using the degree version because when we find that angle theta, you'd probably be finding it in degrees. So far, so good with my setups here, Taylor? Okay. So first thing I'm going to do is I'm going to figure out what theta is. And that's not too bad because I know that each one of these segments is identical. So there's 360 total degrees in the circle. And I'm chopping that up into 15 segments, so I know that theta is 24 degrees. Good. Good. Well, if you wanted to write it as in terms of radians, that would be okay too. So 2 pi over 15 would be fine also. Now here is the tricky part. If we look at this system that we have, I see 4 variables but 2 equations, right? I have S1, I have R1, I have S2, and I have R2. You agree? If you remember from your Algebra 2 class, to solve 4 variables, we're going to need 4 equations, right? So what's going on here? Did I not get enough information? It seems intractable. Well, here's the trick. Here's why it's sneaky. It's not actually asking us to solve for R1 and R2. It's just asking us for how much bigger is the radius of the outside compared to the inside. So what it's really asking us to solve for is R2 minus R1. So what I'm going to do is I'm going to think about this as equation 1 and equation 2. And I'm going to do equation 2 minus equation 1. So that's going to give me on the left-hand side S2 minus S1. And then R2 times 24 pi over 180 minus R1 times 24 pi over 180. Is that okay with what I did there, Tay? Okay. I noticed that that 24 pi over 180 is the same in each term. So I'm just going to kind of factor that out front. And I get that that can reduce or whatever. I'm just not it's not a high priority because it's not going to be in my final answer at all. So still doing okay? Okay. The next piece here, S1 minus S2. I know what that is. I can rearrange this equation. S2 minus S1 is 1.2. Right? Adding 1.2 to the one side and subtracting S1 to the other. Agree with that? Okay. So I can say 1.2 and then if I just multiply by the reciprocal, that'll give me the difference between R2 and R1, which is what I'm looking for. So very sneaky in that you didn't actually need to solve for, and you actually don't have enough information to solve for R1 and R2 separately. But we do have enough information to solve for R2 minus R1. So when I do that, I get about 286. And what is this? Or are these centimeters? Is that okay, Taylor?
Yeah, that makes sense.
Yeah, very sneaky though, right?
Yeah.
Not likely you would have come up with that. Tough to come up with that on your own, to think about R2 minus R1 as the variable that we're solving for. Grace.
This might be like really dumb, but
Okay.
I don't like, what does theta even, like, is it just like a symbol?
So yeah, so theta is a Greek letter. So like we have the English letters like A, B, C, D, etc. There's Greek letters like alpha, beta, gamma, yada yada. Theta is one of them.
So it's not like a thing on your calculator.
It is not a thing on your calculator, so it's not a constant. So in trigonometry, oftentimes what we do is we use the English letters to represent side lengths or linear distances, and we use the Greek letters to represent angles. So theta is the kind of the de facto, it's like the x of the angle world. Is that? Okay. And again, like, depending on what you remember from your geometry class or what notation your teachers were using, this might be the first time you've seen theta used as a variable commonly. But that's all, it's just like a letter. John.
Is it all right if we do this a different way?
Yeah, I imagine that there was more than one way of doing it. This was what kind of seemed natural to me. What did you do?
Well, I just assigned the arc length value, so it's 1 and 2.2.
Okay. Yeah, that's should be fine to do it that way. And then you use that to solve the R's directly.
Individual equations and found the difference.
Gotcha.
in R.
Yeah. Could that ever pose a problem? I don't think so, since they're concentric. I think it shouldn't matter because the angle will remain constant regardless of the length of the radii, just the ratio that would. So yeah, I think that would be fine. That's a rather elegant solution to a problem that algebraically became kind of tedious here, right? Yeah, so good idea. I like that. Josie?
Can you just do number 31?
31, certainly. So here it says find the exact value for this thing without using your calculator. So whenever we're going to be asked to find at this point, to find the exact value of an angle without a calculator, we're really limited to two situations. We're going to be working in either a 30, 60, 90 or 45, 45, 90 triangles, right? So pi over 6, the first thing I would do is I'd want to find out, like, okay, what angle is that? Is that a 30, 60, 90 angle or a 45, 45, 90 angle? So it's 30 degrees. So I know like sine of pi over 6 is going to be the same thing as sine 30 degrees, right? So that's what I'm going to think about. So I'm going to go ahead and draw my 30, 60, 90 triangle. And again, for you guys, the ratio of these side lengths you'd want to have memorized. So you should have your 30, 60, 90, and 45, 45, 90 triangles memorized. Those are good pieces of information to have. In this case, for 30 degrees, and we're talking about sine, that's opposite over hypotenuse. So that's going to be x over 2x, which reduces down to just 1/2. Does that feel okay, Josie?
Yes.
Yeah, no problem. Was it the pi over 6 that was throwing you?
Yeah.
If it was sine 30, you would have been good?
I got there and I was like, I don't remember what.
Yeah. No problem. No problem. That's what this time is for, right? Just as an aside, the 45, 45, 90 triangle, I might as well mention since we're talking about these. The leg lengths are identical and the hypotenuse is a factor of the square root 2. Margot?
This is kind of like earlier on.
That's okay.
But can you please do number 9?
Yeah, sure. Number 9. 3 pi over 7 radians. Okay. So we have 3 pi over 7 radians. To convert that to degrees, we're going to multiply by pi over 180. And the way I remember which one is which is I think about it like a unit conversion problem. So I have 180 degrees over pi radians. So like the radians on top cancels with the radians on bottom. And then the pi's on top cancel with the pi's on bottom. So really I have 3/7 times 180. So I'll just go to my calculator. Since it says to round my answer, I'm not going to worry about like writing as a reduced fraction or whatever. So I'd say this is 77.14.
Okay.
If you wanted to write it as a fraction, you could do 3/7 times 180 and then, no, this is in degrees. Why would I write it as a fraction? What are you talking about, Mr. Gulick? I don't know. Never mind. Ignore the things that I'd said after the 77 point whatever.
Okay.
Alyssa.
21, please.
21. It's another one of the story problems, right? Pizza shop owner decides to cut a round pizza into 10 equal slices if the diameter of the pizza is 18 somethings. Grace and Aaron. Oh, sorry, Grace Yaklin. My apologies. I need to make sure I'm being specific. I have twice as much Grace as usual in this class.
I was so excited.
I know. My apologies. You wasted all those steps.
I know, it was really long.
Oh, what is the length of each piece of crust? Round your answer to the nearest hundredth. Okay. So let's draw ourselves a picture. So Draw our pizza slice here. It's a round pizza, so we're going to have like these triangular pizza slices. It says that it's cut into 10 equal slices. So what that's going to give me is that theta is 36 degrees. Okay with that, Alyssa? Okay. And it says the diameter of the pizza is 18 inches, so that tells me the radius is 9. You good with that?
Yeah.
And it says, what is the length of each piece of crust? That's this, which is my arc length S. So S is going to equal R times theta times my conversion factor, pi over 180. And now it's just calculator time. So 9 times 36 times pi divided by 180. Oops. I had a whole bunch of other googly-got going on there. Try it again. 9 times 36 times pi over 180. So 5.65 inches. Does that feel okay, Alyssa?
Yes, thank you.
You're welcome. Grace,
Will you do number
26?
26?
Sure. So 26, we're given a right triangle and some values for the side lengths. I'm just going to write the values for the side lengths on the triangle, even though that's not exactly how it's given in the picture. But that's what they'd want you to do. You good with that?
Yes.
Okay. And then it asks you for the 6 trig, or the value for the 6 trig functions. So sine theta relative to this theta, we have this side is the adjacent, this side is opposite, this side is hypotenuse, right? The definition for sine is opposite over hypotenuse. So that's going to be 3 over the square root of 58. But we don't leave a radical in the denominator when it involves just a number like this. So we'll just multiply the top and bottom by square root 58. And that'll get that guy out of there.
And then for like the other ones in that section, like you solve them the same way.
Right, so let's just finish them up here. So cosine 50, or cosine of theta is 7 over square root 58. And I'm not going to show the work for rationalizing the denominator there. I'm just going to write the answer. And then tangent theta is opposite over adjacent. And then my other 3, the 3 likely new ones, cosecant theta is the reciprocal of sine. So I'm going to look at this one. I'm just going to flip it. Hypotenuse over opposite. Then secant is the reciprocal of cosine. So that's hypotenuse over adjacent. And then cotangent is the reciprocal of tangent. So that would be adjacent over opposite. Does that feel okay, Grace?
Yeah.
You didn't convince me.
No, it's fine. Thank you.
Okay. You're welcome. I'm still not convinced. Raylan. 16? Sure. Okay. 16, we're just asked to find the missing value. So we know that S is 418. R is 1.7. Since they're the same unit, I'm just going to drop the unit because it doesn't really matter to us. And we're looking to find theta, right? So it depends on how you want to write theta. Do you want to write theta in terms of degrees or radians? I'm going to use radians because, well, it's just like a lot less work. And the question doesn't specify that I have to use one versus another, so I'm just going to do the radian version. So 418 divided by 1.7 gives me 246.
Oh, so it doesn't matter if it's degrees or radians?
No, if you wrote the answer in degrees, the answer there would be multiply by pi, or 180 over pi. So 140.88 would be fine also. It doesn't specify which one it wants. Either would be fine. Is that cool?
Yeah.
You're welcome. Jose.
Can you please do 39?
39. Okay. So 39, we're given a right triangle and asked to find a specific part of it. So I'm just going to go ahead and skip to filling in the values. Okay, there. So the angle that I know is the one that I'm going to worry about. Relative to the 38, the 10 is the adjacent, the blank side is the opposite, and the side we're interested in is the hypotenuse. So far, so good. So the side that I know as adjacent and the side I want to know is the hypotenuse. So the trig function I need to use involves adjacent and hypotenuse. I should choose cosine, because cosine is adjacent over hypotenuse. So far, so good. Okay. Keep in mind that the trig functions, sine, cosine, tangent, all operate on angles. So the thing inside of sine, cosine, and tangent always needs to be an angle measure. The inverse trig functions, sine inverse, cosine inverse, tangent inverse, operate on a ratio of side lengths and then give you back an angle measure. Anyways, so to solve for C, I'm going to multiply both sides by C. And then divide both sides by cosine 38. Remember, cosine 38 is just like a crummy decimal. So you could convert it into a decimal at any point, but beware of like rounding errors from like repeatedly having to round some of these intermediate steps. I like to just leave it all as just cosine 38 till I'm ready to put it in my calculator. So that's 1269. And my check here would be to just go back and make sure that that is the biggest side, since we're solving for the hypotenuse, right? Got to make sure that answer is bigger than 10, which it is. Does that feel okay? Okay. Who's next? Elizabeth?
So for the first section, you just like take the degree and like
Yes. That is our conversion from degrees to radians, is pi over 180.
and then you put it in your calculator.
And you just type in your calculator and write down the decimal, rounded to 2 decimal places per the instructions. But yeah, that's it. Oh, it says leave your answers in terms of pi when applicable. So you can leave it as a fraction of pi is the preference. But you wouldn't do that on like 2, 4, or 5 because they're decimals. And maybe not even on 6 because that's not sure that's going to reduce real well. Margot?
You do 38.
Yeah. So it says evaluate using your calculator. And then do some rounding here. So secant of pi over 17. Now there's no secant button on my calculator, right? So what I'm going to want to do is I'm going to rewrite this in terms of sine, cosine, or tangent because I do have those buttons on my calculator. Secant is the reciprocal of cosine. So I'm going to do that into my calculator. And since I have my angle here in radians, before I go and do this in my calculator, I'm going to change my mode back into radian mode. It was previously in degree mode. So I'm just pressing the mode button and then changing that to radian mode. So I have 1 divided by cosine of pi over 17. So that's going to be 1.0, what did it say? Thousandth. 1.017.
That's all.
That's it. So just to be clear, 1 over cosine, again, is the same thing as doing cosine and then doing the -1 at the end, which is not the same thing as cosine inverse. Cosine inverse is its own separate function. It's not the same thing as the reciprocal of cosine. Everybody cool with that? Okay, so it's an easy piece of notation to get mixed up on. So 1 over cosine is not the same thing as cosine inverse, just to be clear. That typically comes up every year. Grace.
Okay. So this is like another question about like the triangle one.
Sure,
You're like 27, because they only give you like 2.
that's
They
okay.
only give you 8.
Okay, no problem. Sure. So you're given 10 and 7. So the first thing I need to do is find this third side, right? How do you find the third side of a right triangle? Pythagorean theorem. So a squared plus b squared equals c squared, where the a and the b are the legs of the triangle, and the c is the hypotenuse. So 49 plus b squared equals 100. So b squared equals 51. And when I square root both sides, I can drop the plus or minus. Since we're talking about a side length, it has to be positive. I can just call it square root 51. Grace, are you okay with what we did there? Okay. From here, it proceeds exactly the same as 25 or 26 would have. So I would just say, okay, my angle theta is still here. So sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent, but I got to rationalize that denominator. So far, so good, Grace? Okay. Cosecant is the reciprocal of sine, so it's hypotenuse over opposite. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. But we got to rationalize that denominator. And cotangent is the reciprocal of tangent, so that is adjacent over opposite.
Okay, thank you.
Yeah, you're welcome.
Are we gonna have to memorize all those? Like how to do the, or like the adjacent over, what, like,
So my suggestion to you is to just remember which ones are the reciprocal pairs.
okay.
So that way I'm just going to remember, I know SOHCAHTOA already. If I know cosecant is the reciprocal of sine, then I know it's hypotenuse over opposite because it's just the reciprocal of what sine was, right? So I would suggest remembering the reciprocal pairs, and then you don't have to remember anything else.
Okay.
And that also is more valuable moving forward.
Okay.
That piece of information gets used over and over and over again, where we abandon opposite over hypotenuse pretty quickly
Okay.
as we extend these definitions into non-right triangles. Elizabeth.
Okay, I'm kind of confused with the whole chart thing.
Yeah. So these are all their own separate problem, right? So 13, you don't know what S is. You know R is 1.2, and we know theta is 2.1 radians. So because we're in radians, I'm just going to use S equals R theta, and then plug in my value for R and my value for theta, and that's it. So it's just using that S equals R theta, the appropriate version of that formula, depending on whether you're in degrees or radians, to solve for the third part, is all you're doing just over and over again. So each one is its new situation, like the numbers for the first row don't impact the numbers for the second row or for the third row. It doesn't build off itself. Does that feel okay?
Yeah.
You're welcome. I knew this just had to be like, I didn't understand the format of the question because it's quite an easy question, right? Yeah, just confusing way of presenting it. But. Alyssa.
24, please.
Sure. So 24 is just a unit conversion problem, similar to like what we did in the example at the end of section 2.2. So it says a circular saw has a diameter of 8.25, and we got 12 teeth per inch. And we know that the saw spins at 3,500 RPMs. And we want to convert that to teeth per second. So far, so good? Just writing down what we know. So I'm going to start with the 3,500 RPM. I'm going to write that as 3,500 revolutions per 1 minute. So the first thing I'm going to do is convert revolutions into linear distances. I know that 1 revolution is 1 circumference. In this case, that's going to be pi times the diameter, or 8.25 pi. So far, so good? Okay. So when I do that first multiplication, the revolutions cancel, and I'm in inches per minute. The next thing I need is to try to get this into teeth. So I have this 30, I need to convert this into seconds because I'm currently in minutes. So I guess it doesn't matter when I do this, but at some point I need to do this. So I know 1 minute, there's 60 seconds. So there the minutes cancel. So I'm in inches per second. And now I'm going to convert these inches into teeth. So I know that I have 12 teeth in 1 inch. So those cancel. And my units will be in teeth per second. So all I have left to do is to type this into my calculator. So 3,500 times 8.25 pi. I'm not going to bother with the times 1 and then times 12. And the denominator, I'm not going to bother with the times 1s. I'm just going to put the 60 in there. So I have 18,142 I guess it doesn't tell me how to round it, so we'll just maybe call it 1841 or 18,143 or something, right? Oops. Is that okay?
Yeah, thank you.
Sure. And again, kind of the order that you do that conversion doesn't really matter, right? I was just kind of, it just, because it's multiplication, you can have those conversion factors in any order. Natalia. Okay. So the easiest way to do this is to just let your calculator handle the majority of the work. So we're multiplying by pi over 180, right? On my calculator, I'm just going to ignore the pi and then just add it on at the end by hand. So I'll do 80 over 180. And I'll press the math button and choose the fraction command. So that just gives me that it's 4/9. And then I'll add the pi on myself. Yep. The other way you can think about it is just like 80 over 180 times pi, and you can reduce by hand. So like divide both the top and bottom by 10, and you can divide both the top and bottom by 2, and you end up at 4/9 pi also that way. Doing it by hand, but you know, like I know you guys can reduce fractions by hand, like, but sometimes it's tedious. Let the calculator do the tedious stuff. That's what it's there for. Marks.
How do you know to put the pi next to the 4 and not the 9?
Because if you look at the multiplication that's going on here, where's the pi?
Oh,
In the numerator.
got it.
So it should go in the numerator. No, sometimes like it's one of those that's like, oh yeah, sure, of course, but you don't think about it that way until like you point it out to you. And you're like, oh yeah, of course. Why didn't I think of that? And it's like, well, because it's the first time you're doing it. That's why. Grace.
Could you do it on 29?
Sure. So it says, assume theta is a acute angle in a right triangle. So I'm going to start by just doing that. Satisfies the given conditions. Find the values for the other 5 trig functions. So I know sine theta is 4/7, which I know is opposite over hypotenuse, right?
Yes.
So the side opposite theta is my 4, and the hypotenuse is the 7. Now I'm going to find this third side using the Pythagorean theorem. So far, so good. And now it's just like 25 through 28. So I'm going to stop. Are you good with me stopping there? Okay. You're welcome. Raylan?
I know 23 is the same process as 24, but after all the visits, do that.
Sure. So the diameter is 22 inches. And I know that 1 revolution is 1 circumference, which in this case is 22 pi. So I'm going to go convert from 14 miles per 1 hour into revolutions per minute. So I'll start by converting hours into minutes. And then I'm going to convert.
I brought a tissue box.
Thanks.
Yeah. Where should I put it?
Maybe on top of the file cabinet or something. So it's not on, like somebody won't walk into the desk and be like, oh, free tissues for me. Thanks, brother.
Of course.
So 5,280 feet in 1 mile. And then there's 12 inches in 1 foot. And I need to go all the way down to inches because that's what my circumference is in, right? Is in inches. So then I can go 22 pi inches in 1 revolution. So when I reduce things down, I'm left with revolutions per minute, which is what it's looking for. So my suspicion is we probably just typed something wrong into our calculator. But so I'm going to go ahead and put the entire numerator in 1 set of parentheses. I skipped the ones. And then division, parenthesis, and I'm going to put all of the denominator kind of all together and close the parenthesis. And press enter. So 23, 52, 94. Yeah.
When you're typing into the calculator, you put 2 pi instead of 22 pi.
Oh. Thank you. So probably you're wondering like, hey, Mr. Kulik, that's not the right answer either. How about 213.90?
That's what I got. That's not what the answer key said.
The answer is
Oh. What's the answer key say?
it's just in revolutions per second.
Yeah, it says 3.565 revolutions per second.
Oh, it just gave an answer in revolutions per second. Well, that's rude. So if we divide this by 60 again, we should have the answer in the... Right? That's what it said? Okay. Well, there you go, Raylan. 213 answers the actual question. You divide by 60 again, and you get the answer in the book. Because it gave the answer in revolutions per second rather than per minute. The question asked per minute. Apparently, the answer key is per second.
So wait, the one you got first, right? Because it doesn't ask a minute.
Yeah, so this is the actual, this is what the answer should be.
Okay.
The answer in the book is an equivalent answer, but it's the wrong unit.
Okay.
You know what I mean?
Yeah.
Be like, in feet, how tall are you? And you're like, I'm 1.78 meters. It's like, well, that is how tall I am, but you give it to me in the wrong unit kind of thing. Like it's correct, but you didn't answer the question. You know, like the book answer is correct. It just didn't answer the question. You know what I mean? You know, it's dumb. Elizabeth.
Can you just do like 42 and 44 on the lowest?
42 or 44?
I'm sorry, 43 or 44.
Oh, sure. Do you have a preference?
You do 44.
Sure. It says find the values of two different angles coterminal with the given angle. One of your answers must be positive and the other must be negative. Okay. So just to kind of rehash, what do we mean by coterminal? So we defined an angle in standard position where one arm of the angle is the initial side on the positive x-axis, and the other angle starts, or the other arm starts at the positive x-axis and rotates counterclockwise through whatever the angle measure is, right? So this one is, say, r theta. I'm just recounting what coterminal is. I'm not actually doing a problem yet. So when we say coterminal, that means I want another angle whose terminal side, that's this side, is in the same position. So what does that mean? It means that, like, say we go around more than once before we get there, or you could go clockwise instead of counterclockwise to get there. So far, so good? Okay. So what does this mean for us in terms of this problem? We're just going to be adding or subtracting 360 degrees from this angle. Now, since this angle's in radians, instead of adding or subtracting 360 degrees, I'm going to be adding and subtracting 2 pi, which is the radians equivalent of 360 degrees. So if I add 2 pi, that'll definitely give me a positive angle, right? Everybody agree? Because I'm adding 2 positive numbers. So I got to make a common denominator. That common denominator there is clearly going to be 7. So I have 2 pi over 7 plus 14 pi over 7, which would give me 16 pi over 7. So there's one angle that's coterminal. So far, so good? To get a negative angle that's also coterminal, well, instead of adding 2 pi, I'm going to subtract 2 pi.
Sorry to interrupt, Mr. Cooley.
It's okay.
Josie Blue and Margot Santino,
They're both here.
they have get out of jail early 3 cards today. I don't know, am I giving these to the right people?
Yes.
Okay, check it in. Okay, thank you.
I like that somebody else calls them get out of jail free cards. It's funny because we're implying that school is like jail.
Oh.
So just doing the same thing, subtracting 2 pi this time, making my common denominator, and I get a negative value, so that's a negative angle, so that's good enough. Let's say just for hypothetical, if I didn't get a negative angle here, what would I have to do? Just keep subtracting 2 pi until it gets negative 1, you know?
Is it always 2 pi?
Always going to be 2 pi. Yep. And just FYI, you could do this on your calculator also, right?
So it's like the same thing, but just different size.
Yes. So like, again, you could do this all on your calculator. Like I can do 2/7 plus 2, math frac, 16/7, and then just tack the pi on at the end. And then 2/7 minus 2, math frac, negative 12/7, tack the pi back on at the end. Is that cool? So again, just showing you how to do the fraction stuff on your calculator without having to grind through the common denominators and all that jazz. Hogs.
Can you just go over what S, R, and O are again, like what they represent?
Sure.
I get how to do the math. I'm just confused.
Yeah, no problem. So say we have some circle. And say we're looking at an angle whose center or whose vertex is at the center of the circle. This arc from like A to B is S. The radius for this circle is R, so that's AC. And theta is the angle measure for angle ACB. Does that feel okay?
Yeah.
So S is an arc, R is a linear distance, like a straight line, and then the theta is an angle measure. Cool? That's what you needed? No problem. Sometimes the picture is worth 1,000 words, right? Grace.
So for 43,
Yeah.
you would do the same exact thing as 44, like you add 2 pi over 1. Right?
Well, here, 43, the angle's in degrees. So instead of using 2 pi, I would use the degree equivalent, which is 360.
Okay. So you would add 360 to 1.
Mm-hmm. Yeah, so remember that like pi is the same thing as 180 degrees. So obviously 2 pi should be 360 degrees, right?
Okay.
This we used for our conversion. All right. Let's pause here.